Welcome to the presentation of DBdoctor, a fine-grained and non-intrusive performance diagnosis platform for databases. Accurate and timely diagnosis of performance anomalies is crucial for production database systems. However, current database diagnosis tools face three core challenges. First, the unfavorable trade-off between granularity and overhead. Existing tools rely on sampling-based performance monitoring. They may either miss critical but fleeting root causes of anomalies or suffer from the high overhead of intensive sampling. Second, the black box diagnosis. Existing tools cannot capture and reconstruct the internal context of the database system at the time of the anomaly. For example, they may alert on deadlocks, but cannot reconstruct the transaction dependency graph to identify the precise root cause. And finally, though large language models are powerful and increasingly applied to database diagnosis, they tend to hallucinate without high-quality database context. We simply can't trust unverified, generic advice in a production environment. Now, let's walk through the architecture of DBdoctor. First, let's look at the observation layer. We address the limitations of sampling by using eBPF to capture the continuous event flow from the database instance. eBPF probes can collect key metrics at function calls with low overhead and without modifying the database. The Adaptive Probe Manager can dynamically adjust the probe set to probe the most relevant functions to database anomalies. Next, moving up to the diagnosis layer. Here, we use the pre-processed events to reconstruct the full database context to pinpoint the precise root cause of anomalies. Then, the resolution engine leverages large language models to provide candidate resolutions based on the database context and root cause. The language model is aided by a knowledge base containing historical anomaly resolution cases through RAG. Before reaching the users, candidate resolutions are verified by the cost model and SQL auditor. Finally, in our user interface, we transform complex data into intuitive, interactive visualizations, including real-time monitoring, lock-weight graphs, and an AI assistant chat panel. This gives you a unified dashboard where you can easily identify anomalies and interact directly with the system to find the root causes and apply resolutions. Now, let's see how to interact with DBdoctor. Here, click Example Management button. You can set up a new database instance. You can set your instance name, choose type, and you should set your database account and password to allow DBdoctor checking meta info. To enable eBPF collection mechanism, you need to set host IP, account, and password for installing eBPF agent used by DBdoctor. Here, we already set up an instance for demonstration. Let's see how DBdoctor monitors it. Here's our main dashboard. Take a look at the CPU anomaly right at the top. This is a millisecond level spike, which traditional sampling tools would usually miss, but DBdoctor captured it instantly through our eBPF probe mechanism. You can change the selector on top to view different time range of the monitor. The bottom dashboard presents the long transaction and deadlock anomalies. It uses database context and analyzer to pinpoint the root cause. If you want to view the detailed information that how a deadlock happened, you can click the Lock Perspective item. Here, click Deadlock Visualization Analysis. You can see the cyclic graph that how transaction A, B, and C blocks each other, and which resource they hold cause the endless wait. The lower part shows the timeline of the deadlock. It clearly displays the scene of the resource occupation among three transactions. It reveals how lock contention happened and pinpoints the precise timing of critical events. Now, let's back to monitoring dashboard. If your mouse hovers on magnifying glass icon, a floating window will occur and you can click the AI Diagnostics button to get detailed suggestions. As you can see on the right, the report is composed of three parts: phenomenon description, root cause deduction, and verified recommendations. The content is generated with the assistance of the SQL auditor and RAG based on accumulated case studies. Also, the recommendations have been verified for both validity and effectiveness via cost model. For now, DBdoctor helps over 500 companies to diagnose database. Thanks for watching.